Hi guys! Welcome ulit sa YouTube channel natin. Now today, we are actually live. Now at least no, nung na-record tong video na to, live kami sa Zoom. So anyway, shout out pala sa ASEP CIT-U student chapter in organizing this CE tutorial series. So ginawa nila to in preparation to help the students para sa midterm exam nila. Anyway, yun nga, naimbitahan ako para maging speaker. So ang ituturo ko ngayon is actually itong theory of structures. Now, specifically yung influence diagram of beams. So, although medyo mataas tong live natin guys, 2 hours kasi tayo. So, I hope na may matutunan kayo. Now, don't worry, rest assured may matutunan kayo. And then, I'll do my best no, to na paabutin to sa influence diagram of trusses, but I don't think kaya. But anyway, as much as possible, no, I'll do my best. But focus muna tayo sa influence diagram of beams. Okay? So, meron akong tatlong method na ituturo, but rest assured, yung last method is magagamit nyo sa board exam. Okay? So, anyway, yung dalawang method na yon medyo madali, but medyo mahirap din. But yung last method, napakadali, and yun yung gagamitin nyo sa board exam. So, anyway, I hope na makatulong ako, especially sa mga nagtitake ng nagtitake ng theory online classes. So, maraming salamat, and of course, enjoy the video. Okay. Hi pala. Welcome no sa mga nanonood dyan. Anyway, I was expecting na medyo madami tayo sa Zoom. So, mga kaunti lang tayo sa Zoom, but yun nga, gaya ng sabi nila, medyo madami tayo sa Facebook Live. Now, unfortunately, I was expecting no, na meron tayong interaction ngayon. But anyway, so itong nasa Zoom Live natin. So, sila na lang yung magtatanong in behalf sa inyo. So, if ever meron kayong tanong, you can ask. You can chat them, no? And then you can try to ask, okay? And then i-chat nila sa akin yung tanong nila dito sa Zoom. Anyway, before I start, no, maraming salamat sa pag-invite sa akin dito sa CE tutorial series ninyo. Now again, the main purpose of this tutorial series is of course to prepare you sa midterm exams. Now I hope I hope na ang i-discuss ko actually is also a part of the coverage then sa midterm exam ninyo. Now, I myself, I'm Engineer Marvin Ibola, no? And then I'm actually a full-time instructor din sa CIT-U. In fact, yung iba dito, under ko sa theory. Shout out sa mga under ko sa theory. Ito, si Ortega. Si Ortega lang ata, hindi ko kilala yung iba. Anyway, sandali lang ha. Okay. So, anyway guys, ito yung gagawin natin ngayon. So, I'll try to discuss. Actually, kaunti lang yung topics kasi nga limited. So, anyway, I'm trying to prepare you know, sa midterm exam. Now, sa akin, kasali yung influence diagram, influence lines for beams and trusses sa coverage ng midterm exam. Now, nag-ask din ako kay Ma'am Aying, okay, coverage din to sa midterm exam, yung influence lines sa beam and truss. Now, kay Sir Solena, hindi ko natanong, but I think kasali dito yung influence diagrams. Maybe next week ata, i-discuss. Okay, now as we all know, September 19, yung exam natin sa midterm. September 17, 18, and 19 ata, yung sa midterm exam. Anyway guys, yan na. So, let's start. So, I'll be discussing this topic, influence lines for statically determinate structures. Now, originally, I was asked to discuss itong structural analysis of beams and trusses. Okay, now, unfortunately, yun nga, para sa akin, I think, kayang-kaya niya na yun. Okay, kasi yung beams, as you all know, no, yung solving the reactions of beams and trusses, na-discuss na yan during sa statics. Okay, in fact, isa rin akong instructor na last semester sa statics, so I actually discussed yung sa beams and trusses. Okay, yung reactions and analysis of beams and trusses. Now, with regards to the moment diagrams and shear and moment diagrams, na-discuss din dapat yan sa strength of materials. Okay, so anyway, ang class ko sa theory, ang ginawa ko na lang sa kanila for the analysis of beams and trusses, ang ginawa na lang nila is yun nga, I just reviewed, okay, so binigyan ko na lang ng problems, and then yun nga, I was as expected, nasagutan nila, but still meron silang mga counting tanong, no, to refresh them. Anyway, so kaya nag-skip na lang tayo doon. Okay, so focus tayo dito sa topic na to, influence lines for statically determinate. So, influence lines for statically determinate structures. Okay? So, anyway, ano bang silbi ng influence lines, no? So, by now, no, tapos na kayo dapat sa mga loading. Dapat alam niyo na kung ano yung mga loadings. Okay, so anyway, meron tayong dead load, di ba? At saka meron tayong live load. Now, so far guys, sa mga previous topics ninyo, ang na-discuss actually ninyo, okay, or I'll just assume no, ang na-discuss ninyo is itong dead loads or fixed loads. Now, ano to? Yan. Now, sa dead loads at fixed loads, usually guys, ang ginagawa natin no, to determine the variation or the effect of those loads dito sa beam natin, meron tayong ginagawang shear and moment diagrams, di ba? Naalala nyo to? We have, for example, pag meron kayong concentrated load, yan, meron tayong ganito yung shear diagram natin, and then linear, okay, yung moment diagram natin. Likewise, pag meron din tayong uniformly distributed load, we have a linear, okay, linear yung shear diagram natin, and then parabolic naman, kasi plus 1 degree yan, di ba? So, anyway, this is just a review na lang. And then we have the, pag uniformly varying load naman, parabolic yung shear diagram, and then we have a cubic para sa moment diagrams. Now, itong mga diagrams na to, shear diagrams, moment diagrams, okay? These are actually used, no? Magagawa natin to pag ang load natin is yung tinatawag na dead load or fixed load. Meaning, yung load na yan, that is actually constant for the beam, okay? Nandyan yan. Okay, now, sa structural theory, meron tayong iba ding, another type no, of loading, which is yung tinatawag nating live load, okay? So, sa live load, guys, yan, pag live load or moving loads, guys, ang mangyayari is, hindi natin pwedeng, well, hindi naman na hindi pwede, but mahirapan tayong gumawa ng shear and moment diagrams. Bakit? Kasi itong live load or moving loads, yun nga, from the name itself, no, gumagalaw kasi yan. So, yes, okay, kung ang live load or moving load mo is nasa gitna. Ito yung shear diagram yan, at saka ito yung moment diagram. Okay, but, what if, guys, okay, what if yung load natin is, since moving, okay, instead na nasa gitna, siguro nandito, sa kabila, okay, or nandito sa, at a distance dito, okay, malapit sa kabilang support. So, you cannot actually capture, no, at saka kung i-capture mo man, napakadaming shear and moment diagrams. Kaya, dito napapasok yung influence diagrams, okay, or influence lines. Actually, itong mga lines, kasi nga lines lang kasi yung mga diagrams natin, but these are actually also known as influence diagrams. Now, itong mga influence diagrams, ito yung ginagamit natin, guys, to capture no, the variation of this live or moving loads sa beam natin. Okay? So, for example, meron tayong moving load. Okay? Now, itong moving load na to, since hindi natin alam, since moving yan, so hindi natin alam exactly, okay, kung saan yan, kung saan yan sa beam, okay, along the beam. So, we will just call this distance, no, from A, siguro at X. Okay? So, that is an unknown distance. Okay? So, yung distance X na yan, okay, yung distance X na yan, depende yan, pwede ang X at 4, so pag 4 ang X, meaning nandito sa C. Okay, pag ang X is actually 8, meaning the load is actually nandito sa B. And then pag ang X naman is 12, therefore ang load is nandito malapit sa overhang. Okay, so anyway guys, we can actually create an influence diagram. Okay, pwede tayong mag-create guys ng influence diagram na magdi-describe yung variation ng loading na to ba. But okay, but at a specific point only. Okay, therefore we will create a influence diagram for a specific point. Now in this case, okay, or a specific part no, sa beam. Now in this case, itong part na to, ito yung C, yan joint C na yan. Okay, so anyway, skip lang natin to. Ipapakita ko na lang yung at least no, meron kayo idea sa mukha. But don't worry guys, sa mga next slides, I'll actually teach you no, how to create these shear and moment diagrams. Okay? So, influence diagrams pala. Sorry. So, anyway guys, ito na yan. Okay, so, tingnan nyo, ito yung mukha ng influence diagrams natin. Now, this is actually the influence diagram for the shear, okay, at C. Again, take note, influence diagram for the shear at C. Don't worry guys, tuturuan ko kayo kung paano gagawin to. And then, ito naman, this is actually the influence diagram, yan, for the moment at ito C din. Okay? So anyway guys, hindi pala to for the moment at C, iba pala to, sorry. Iba yung figure na ginamit ko. Anyway, parang ganito yung mukha natin sa influence diagram. Sorry guys, iba pala to. Hindi ko napansin. Iba to. This is actually another influence diagram for another beam. Hindi to ganito. Okay? But, parang ganito yung mukha, no, ng mga influence diagrams natin. Kung mapapansin nyo, lines lang, no? Kaya tinatawag natin yung influence lines. Okay? Now, don't worry guys, madali lang to. But, take note, ito yung importante, no, sa influence diagram natin. Notice na sa diagrams natin dito, meron tayong dalawa ding axis. Okay? Tignan nyo, meron tayong x-axis. Yan, yung x-axis na yan. Now, the x-axis is actually similar lang sa natutunan natin dito sa shear and moment diagrams during sa strength of materials. Okay? Yung x-axis actually represents the length of the beam. Okay? So, simula ka dito sa 0. So, meaning, pag ito 4, this is actually andito sa C. Yan. Pag ito 8, this is actually andyan sa support at B. Okay? So, anyway, yan. Meron tayong x-axis and same pa din, meron tayong y-axis din. Now, the y-axis, depende din yan kung ano yung function na hinahanap natin. So, kung shear, meaning our y-axis is actually, yan, yung y-axis natin, that is actually yung shear din. Okay, so for example, pag moment, yung y-axis mo, moment din. Now, unlike dito sa shear and moment diagram, guys, na yung intensities natin, for example, yung height nito is actually equal, okay, to the moment specifically dito for that beam. Now, dito sa influence diagram, guys, iba. Okay, yung mga height nito, yung height dyan, yung height, for example, ito, ang height ng influence diagram sa shear at C is actually dito, yung positive, that is actually 0.5. Now, these are not the values of shear directly. Yan, hindi yan mga shears. Okay, tawag natin dyan ordinates. Okay, tawag natin dyan ordinates. Anyway, I think, no, yan lang ata, no? So, ang importante lang na at least meron kayo yung idea, okay, sa pag-influence diagram, you have x-axis, y-axis, and then, ang tawag natin dito, ordinates, okay, yung height ba? Okay, for example, yung ordinate of the influence diagram dito sa overhang is actually negative 0.5, ganun. Those are actually ordinates, while x-axis is the length of the beam, okay? Now, let's proceed down sa next slide. Yan. Now, sa next slides, tuturuan ko na kayo kung paano natin gagawin yung, paano natin iguguhit ba, okay? Or, yun nga, gagawin yung influence diagrams. Now, meron akong tatlong method. I think tatlong method lang ata yung ituturo ko sa inyo. But, meron pang mga ibang method, ha? But so far, itong tatlo lang ata yung na-introduce. In fact, during sa undergrad ko, I think itong dalawa lang yung naituro. Now, itong last method, ito yung ginagamit namin sa board exam. Okay? Especially ito yung tinuturo ko sa review sa Bisabilia. Okay, so tuturuan ko muna kayo sa first two methods. No, itong first two methods, guys, medyo madali but mataas. Okay, madali lang siya but medyo mabagal tayo maka-create or maka-draw ng influence diagram. But yung last method natin, which is yung preferable method natin, no, especially when we're taking the board exam, ito medyo mahirap but napakadali gawin. Okay, actually, since napakadaling gawin, so I think medyo madali na lang din. Okay? So anyway guys, let's proceed muna sa first method. Yan. The first method, guys, is ito. Tabulating the values or tabulate values. Yan. Now, sa method na to, guys, ang gagawin natin is yan o yan. So yan yung steps natin. Anyway, the first step daw is to place a unit load at various locations of X. So ang mangyayari dyan, guys, is parang ganito. Yan o. For example, meron kang beam. Yan. Now, sa beam na yan, guys, again, asan yung C? Halimbawa, nandito yung C. Yan, yung point C na yan. Now, we are interested, no, for example, to draw the shear diagram sa point C. Ang mangyayari, guys, is hindi natin, hindi shear diagram, shear influence diagram, no, for the shear at C dito. So, hindi natin alam, hindi natin alam kung saan yung load, okay? That is actually moving load. So, pwedeng nandito, pwedeng nandyan, pwedeng nandyan, pwedeng nandyan. Okay, hindi natin alam. But, isa lang. Okay, moving load kasi. So, ang gagawin natin, guys, since hindi natin alam exactly load, we will just select specific points, okay, sa beam natin, and then solve for the shear at those points. Okay, ang mangyayari, tingnan natin dito. Yan o. Tingnan nyo. Okay, and then use statics to determine the values of the function. Now, in this case, kanina, for example, shear. So, ilalagay natin individually yung unit load, again, unit load lang ha, yung unit load ilalagay natin dito or dito sa mga parts ng beam, and then after nun, we will actually try to solve for the shear, okay, the shear, using yung method natin which is yung statics na lang. Okay? And then after nun, guys, to avoid errors daw, as much as possible, we will try to create a table. Okay? Na bakit gagawa tayo ng table? Balik tayo dito sa previous slide. Yan. Now, kung mapapansin nyo, guys, meron tayong x-axis and y-axis. So actually, itong influence line na yan, those are just set of points. So, ang target natin is to get those points and then connect those points to create this diagram. Okay, now, pag alam natin, pag points, meaning, meron tayong dalawang coordinates. Meron tayong x and y-axis. Now, the x-axis, obviously, is the length of the beam. And then the y-axis, yun na yun, yung shear, okay? Shear, moment, or reaction, depende. Now, I think, don't worry guys, I think mas madaling maintindihan pag meron tayong example problems. Okay, don't worry, after nito, example problem tayo. Now, the next one, which is, ito maganda, but yun nga, medyo mahirap. But actually, maganda din ang method na to. So, depende na sa inyo kung ano yung gagamitin niyo guys. Okay? So, itong influence line equations na yan, now, the influence line daw can also be constructed by placing a unit load at a variable position x. Kanina, okay, sa tabulate values, specific ang locations niyo at various locations x, but specific. Okay? Now, dito sa influence line equations, hindi specific, unknown yung location ng load. Okay? Don't worry guys, meron tayong example. So, ang mangyayari guys, since unknown yung location ng loads, ang reaction natin, ang shear natin is actually, in terms of x din, variable din. Okay? Yung influence line natin dito. So, anyway guys, I'll try to solve some example problems para makita ninyo and then mas ma-appreciate ninyo itong mga problems. By the way guys, if meron kayong mga questions, you can actually ask dito sa chat para ma-address ko agad. Okay? Chat nyo lang dito yung mga questions nyo. Dito sa ibaba. Sandali lang ha. Set up ko muna. Yan. Okay? So, let's start. Ito so yung first example problem natin. Yan. Construct daw the influence line for the vertical reaction of at A, of the beam. Yan. Itong beam na to. Of the beam. Yan pala. So, again guys, sorry pala guys kung ang units natin is English. Ito kasi yung may mga figure sa book na ginagamit ko. Anyway, meron din tayong mga units na SI. Now, don't worry guys, yung units naman natin hindi magmamatter, okay? So, medyo magmamatter lang siya if we will try to solve deflection sa beams, ganun, medyo mahirapan tayo kasi nasanay tayo sa mga SI na units. Okay? So, let's proceed dito. So, ang tanong guys, influence line for the vertical reaction at A. So, we will actually solve dito sa vertical reaction dito sa A. Okay? So, ang gagawin natin is same pa din. Sandali lang ha. So, meron tayong tabulated values na solution. So, dito ko na lang ilalagay. Transfer ko muna yung beam. So, ito yung beam. Yan. And then, we have, siguro tawagin natin itong AY. Okay? And then, BY. Okay? Anyway, yung beam natin dyan. Okay? So, okay lang pala. So, we have 10 feet long, no? Yung beam natin. And then, we are actually interested, guys, sa reaction, okay, or the influence line for the vertical reaction at A. So, ang gagawin natin guys, tabulated, di ba? Tabulate, yung gagamitin natin na method is yung tabulation niya. So, gagawin ko to. Again guys I encourage you to ask questions. Promise, sasagot ako. So, ilagay niyo lang dito sa Zoom. Ortega ha, ask questions. Yung mga students ko dyan, try to ask questions. Nandito ko ba sila? Okay. Sige. So, anyway, ito yung table ko. Ganito lang yung gagawin kong table. So, this is actually the x-axis. And then, yung kabila naman, the y-axis. Or, since I'm trying to solve for the vertical reaction at A, so, gawin ko na lang AY. Okay? Yan. So, gaya ng sinabi sa description kanina, guys, we will place the unit load, again, unit load meaning 1.0 yung load natin. We will place the unit load at specific points sa beam. So, actually guys, usually ang gagamitin natin ng mga specific points is yung mga quarter points, okay, ng ating beam. Kasi, by the way guys, mas marami kang points na ilalagay, okay, mas marami kang points na i-consider, mas maganda tingnan yung influence diagram mo kasi mag-graph mo talaga, okay, or ma-follow mo. Kasi ang gagawin natin is, we will use these points to connect the graph. Okay, so, mas marami kang points, mas maganda yung lines mo. Okay, now, unfortunately, pag marami ka ding points, marami ka ding i-consider na, i-consider na beams, okay, or i-solve na shear. Now, yun nga, as you try to solve, no, pag marami na kayong mga problems na na-solve dito, in fact, you can just consider 2 points. Okay, if ever veteran na kayo dito ba, just consider 2 points and then you can easily solve, no, the influence diagram of this vertical reaction sa A. But for now, in fact, pwede nga 1 point lang, okay? But for now, ito lang muna, marami muna yung points na gagamitin natin. So, 4 lang muna. So, gaya ng sabi ko, quarter points muna. So, ito, no? So, sorry. Yan, nandyan. Yan, siguro. Dyan. Okay? Now, ano yung mga x values ng points natin dyan? Okay, first is ito. Yan. That is actually at x equals 0. Agree kayo? At x equals 0. And then ito, at x equals 2.5, di ba? 2.5. The other one is 5 and 7.5. Yung last is actually ito. We have 10. Okay, naintindihan lang yung tabulation ng table. Paki-thumbs up lang ha if ever naintindihan yun. Naintindihan lang yung tabulation natin. Bakit x, ay? Okay. So anyway, since okay na tayo dyan, let's try to solve. Ito na yung gagawin natin, guys. We will actually solve itong AY. We will actually solve that AY. So first, guys, let's solve AY assuming na ang unit load is at x equal to 0. So anong mangyayari dyan sa beam natin? So parang ganito. Ganito. Okay. So at x daw is equal to 0, guys, nandito yung unit load na 1.0. Okay? So ilalagay ko dyan yung unit load na 1.0. So ang gagawin ko, guys, is I will just solve for AY. Okay, napakadali, di ba? So, solve ko lang ng AY. So, sum up ako ng moment siguro dito sa B. Okay? So, summation of moment sa B is equal to 0. Clockwise is equals counterclockwise, di ba? So, from our reference point B, the clockwise moment is actually produced, no, by the reaction AY. Tama ba? Tama. So, AY times 10. And then, I think wala nang ibang clockwise moment. So, that is actually equal to the counterclockwise moment. Okay, so that is equal to 1.0 times 10. Agree lang kayo dyan sa... Okay, I hope agree kayo sa solution dyan. Ha? So anyway, we can actually solve now AY is actually equal to 1.0. Okay? So, napakadali, di ba? Napakadali. So anyway, I'll put 1.0 dito. Yan. Okay? And then, ito yung mahirap dito sa method na to. Bakit? Kasi after nyan, buburahin. Okay, wala na to, wala nang silbi to. Bakit? We will now solve the AY if, okay, yung unit load natin nandito na sa 2.5. So, ilalagay ko na naman itong unit load dito sa 2.5, you know, 1.0. And then, again, by the way, this is 2.5, and then this is actually 7.5. Okay? And then, once again, I will try to solve for, yan, AY. Okay, same pa din, guys. Summation of moment at B is equal to 0. Clockwise is equal to counterclockwise. By the way, guys, sa mga students ko, huwag nyo na gamitin yung method na to, okay? So, okay lang ako na if I will give you some problems, no, sa influence diagram, you can use yung method na ginagamit ko sa board exam. Okay? Huwag nyo na lang gamitin tong method na to kasi medyo matatagalan ako yun sa solution ninyo. Okay? But still, at least, it's worth knowing, no, na, okay, ganito pala. Bakit? Kasi mamaya, ito yung gagamitin natin, no, sa pag-solve sa influence line for trusses. Kasi yung trusses kasi, wala tayong magagawa, guys. Ito talaga yung gagamitin natin. Yun bang individual talaga. Kasi pag, dito kasi sa B, meron tayong shortcut, yung Mueller-Breslau. I hope tama yung pagka-pronounce ko, yung Mueller-Breslau principle. Now, sa truss, walang Mueller-Breslau na principle na magagamit. Okay? So, anyway, so pay attention sa method na to kasi ito yung method na gagamitin natin later on sa trusses. But, I discourage this method, no? If you will try to solve for the influence diagram, okay, for the beams and for beams, okay, I discourage this method. But, it's worth knowing kasi ito yung gagamitin natin sa trusses. Okay, so clockwise equals counterclockwise, guys. So, ano yung clockwise natin? AY, no? AY times 10, that must be equal to 1 times 7.5. Okay, therefore, AY is actually equal to 0.75. Okay, obvious ba? By the way, no? Obvious naman, no, na yung AY natin is actually 0.75. Okay? So, anyway, lalagay ko dito, 0.75. Okay? So, okay lang. Naintindihan ninyo yung ginagawa natin? I hope naintindihan, ha? Thumbs up lang ha. Okay, okay. Now, next, I think alam nyo na, no? So, buburahin ko na naman to. Wala nang silbi, no? So, again, ililipat ko na naman yung, uy, sorry. Sorry. Ililipat ko na naman dito yung unit load. So, I think na-imagine nyo na. Okay? Ililipat ko dito yung unit load na 1.0. And then, obviously, no? Hindi na natin i-sum up, no? That is 0.5. This is actually 0.5. Okay? Symmetrical, simply supported beam. Obviously, equal yung reaction since the load is at the center of the beam. So, 0.5. So, ilalagay ko lang dito, 0.5. And then, I think obvious na no, pag ilalagay natin dito yung 1.0, okay, this is 2.5, this is 0.75. Obvious din na this is actually 0.25. Now, let's try to check na lang. Buburahin ko to ha. Sorry guys. Medyo may problem sa lalamunan ko. Yan. So, summation of moment at B is equal to 0. Clockwise is equals counterclockwise. So, the clockwise moments, guys, are caused by, of course, yung reaction natin AY with a moment arm of 2.5 with respect sa point B. And then that must be equal, okay, to the counterclockwise, counterclockwise moment which is caused by 1.0 na load. Okay, and then the moment arm, mali pala. Okay, sinadya ko yun ha, para to check na kung nakikinig ba kayo. So, since walang na, joke lang. So, anyway guys, this is actually 10 yan. And then that must be equal to 1.0 times 2.5. Okay? Therefore, AY is actually 0.25. Okay lang, naintindihan kung bakit 0.25? Again, thumbs up ha if ever naintindihan. Okay, please try to ask questions, no? Plus points pag nag-ask ng questions. Okay, so anyway, after niya, no, I think pwede na. Now, obviously, I think na-imagine natin yung pababa, no? 1.75, 0.5, at saka 0.25. Now, ang next niyan is actually 0. Bakit 0? Tingnan nyo. Tanggalin natin to again. Wala na namang silbi to. Yan. Walang silbi yan. So, ilalagay ko na naman yung unit load dito. Yan, at x is equal to 10, di ba? Now, pag ang x is equal to 10, guys, or yung location, no, ng unit load natin is nasa pinakadulo, no? Obviously, this is hindi na 1.0 na din to. Okay? So, AY is actually equal to 0. Okay? Kahit mag-sum up ka pa ng moment dyan, walang magro-rotate. Okay? Walang magro-rotate. So, AY is actually equal to 0. Yan. Okay? Therefore, guys, yan na. Meron na tayong coordinate points. Yan na yung gagamitin natin, guys, no? To create our influence diagram for the reaction at A. So, buburahin ko to ha? Buburahin ko to. Yan. So, again, ano yung influence diagram natin? Meron tayong two axes, no? X-axis and Y-axis. Okay? The X-axis is, of course, ito yung corresponding length ng beam. Okay? So, anyway, ilalagay ko lang dito. 2.5, 5, and then we have 7.5, and then lastly, we have 10. Okay? And then, ito yung ordinate, itong Y na to, this is actually our, yan, yung reaction, since we are interested sa reaction, that is actually the reaction sa Y. Okay, now, dito na natin ipa-plot, no, yung influence diagram natin. Now, the first point is 0, 1. Saan yung 0, 1? Dito yan. 0 ang X, 1 ang Y. So, siguro ito yung 1.0. So, ang first point natin nandito. Okay, nandyan yung first point. Now, the second point, nandun sa, ito yung second point, 2.5 at saka 0.75. So, 2.5 nandito. And then 0.75 siguro, no? Nandito. Okay? And then, we have yung 5 at x is equals 5. Yung y is 0.5. And then, ito, obviously, ganyan. So, yan. Okay? And then, yung last, yan. So, kung mapapansin nyo, meron tayong 5 points. So, meron tayong 5 points. And then, ang gagawin natin, guys, is just connect the dots. Okay? Connect the dots lang. Connect the points. Para tayong bata, no? Pag connect the dots. Okay? So, connect the points, guys. So, connect the points, yan. Okay. So, obviously, guys, straight line yan. Notice na linear, no? Yung pagbaba ng AY natin, 1.75, 0.5, 0.25. Okay, to 0. Okay, so, ang difference niya is actually 0.25. Anyway, yan na. Okay, yan na yung influence diagram mo. Okay, so, therefore, ito na. Meron ka na sagot. This is our influence diagram. Okay? Yan yung influence diagram natin for the shear, for the reaction at AY. Now, for this beam only. Para sa beam na yan. Now, this method is using, ito yung method na ginagamit, ito yung first method, no? Using the tabulated values. You know? Okay, so sa tabulated values, guys, you need to select specific points along the beams. Now, beginner pa man tayo, so I think mas maganda na ang iselect natin na points is yung quarter points muna. And then later on, pag marami ka nang na-solve, you can actually just consider 1 point. For example, or 2 points, okay? For example, if you will just consider at x is equal to 0, okay? Considering x is equal to 0, guys, automatic 1 yung nakukuha mo. So with that, guys, obvious na, you know, pag meron kang itong point na to, yan, at saka pag meron ka sa point na to, yan, okay? Pag meron ka sa point na dalawang yan, you can actually connect these points. O, diba? Similar lang. You do not need the other, okay, 3 points. Now, guys, be careful. Kasi ang mangyayari, guys, pag ginamit nyo ang method na to, well, pwede yan siguro pag ganyan. Okay? But, not all the time na pwede kang gumamit ng 2 points alone. Okay, don't worry, sa mga next problem natin, papakita ko sa inyo kung bakit hindi pwedeng gumamit lang ng 2 points. But, gaya ng sabi ko, pag meron ka ng, parang veteran ka na ba in solving these kinds of problem, wala, shortcut lang, alam mo na, kahit titingnan mo lang yung beam, okay, ito yung influence diagram. Okay, so pwedeng mangyari yun, okay, using the third method natin, yung Mueller-Bris law. So I hope na tama yung pagka-pronounce ko. So anyway, let's try to solve now this beam. Okay, dapat same yung answer natin, no? Using yung second method, okay? Using the influence line, influence line equations, okay? So anyway, yan yung first solution natin. So proceed tayo sa next, yan. So isosolve ko guys sa same beam, but this time, ang gagamitin ko is tinatawag na influence line equations. Tama ba? Yun ba yung tawag kanina sa influence line? Tama, influence line equations. Anyway, yan. Okay, now sa influence line equation, guys, unlike sa previous method natin at specific points, okay? Now dito sa influence line methods, you will actually consider paano ba to? You will actually consider a variable point or variable distance, no? Now, but still with respect pa din sa A, dito sa A tayo. Okay? Now usually, guys, if you'll try to draw an influence diagram, usually you just consider the consider the leftmost part, no, as your initial point, okay? Diyan yung x values mo magsisimula. Anyway, since hindi ko ilalagay ko, no, so ilalagay ko na lang dito, yan, 1.0. Now, since that is actually a variable distance, no, with respect to our ordinate, no, with respect to our origin, which is nandito. So I hope you will agree na tatawagin ko tong x. Yan. That is actually x. Okay? So, meaning guys, how will I solve for the reaction at AY? Okay? Paano ko isosolve ang reaction ng AY? So, I will just sum up moment, guys. Sum up ako ng moment dito. Same pa din. Paano to? B. I'll try to sum up moments at B. Yan. Is equal to 0. Same pa din. Clockwise is equals counterclockwise. Okay? Clockwise equals counterclockwise. So, ano yung clockwise moment, guys? Obviously, we have AY times 10. Okay? Now that must be equal to, the counterclockwise moment. Now, the counterclockwise moment is, again, obviously, no, is caused by our unit load 1.0. But, ano yung moment arm niya? Okay? Now, I hope you will agree din na ang moment arm nito is actually itong distance na to. Yan. Ano ang distance na yan, guys? That is actually, if yung whole span ng beam is 10, okay, and then the distance, no, from the leftmost part to the unit load is x. Therefore, yung distance ng kabila is actually 10 minus x. Okay, so I hope okay tayo dyan na 10 minus x. Okay, by the way guys, pag tumingin ako dito sa kabila, meaning I'm actually looking at the participants no sa Zoom. So, by the way, pag tumingin ako dito, try to thumbs up lang if ever naiintindihan niyo. Okay, and then check ko din actually kung meron mga tanong dito sa dyan, meron mga tanong sa chat. Anyway, so yan, so that is actually 1.0 with a moment arm of 10 minus x. Tama ba? Again guys, sorry ha, minsan kasi yun nga, mahirap kasi mag-solve habang nagdi-discuss. So minsan kung meron akong mali sa ganyan, okay, minsan sinasadya ko, minsan hindi talaga. So tama, no? AY times 10, okay? Tama lang. So therefore, we can actually solve AY. Yan. So that is actually, ano yan? 10 minus x over 10. Di ba? So AY is actually equal to 1 minus x over 10. Yan na. Sir, ano yung sagot mo dyan? Sir, hindi man yan value, sir. That is actually an equation. Yun nga, di ba? Influence line equation. Now, let's try to draw, okay? From that equation, guys, we can actually now draw our influence diagram. Okay, so i-draw natin, ha? Yan, okay? So, same pa din, guys. AY, at saka ito naman, this is actually x-axis. Yan. Okay, so ito yung purpose ng equation natin. For example, set x, okay? Set x is equal to 0. Pag nandito yung x natin, check natin dito sa calculator. Okay? By the way, guys, I hope meron din kayong calculators dyan. So, 1 minus, ano yan? 1 minus x over 10. Now, let's calculate this function, no? If x is equal to 0. Ano yung sagot? 1. Therefore, nandito pala. Okay? Nandyan pala. 0, di ba? 1. Okay? Now, sabihin ko na lang, tinatamad ako, mag-skip ako. Gusto ko agad 5 na lang. Ayoko na sa at x equals 2.5. Okay? Skip ko na lang. Okay? So, x equals 5 na lang agad. So, ano yung sagot ko? Tignan nyo. 2.5. Dito pala. By the way, ito yung 5, no? Yan, 5. And then, ito yung 10. Okay? And then, lalagyan ko lang at x equals 10. Siguro 10 lang, 10 lang, sir. 0. Again, connect the dots. Ay, bakit hindi na-connect? Sorry, guys. Anyway, see? Same pa din yung sagot natin. Okay, now, depende na sa inyo, guys, kung ano yung method na gagamitin nyo or mas advantage sa inyo. Now, ang maganda dito sa, paano ba sasabihin to, ha? Ang maganda kasi dito sa isang method na to, itong yung, itong influence diagram, no, for, ito pala yung using ba, yung equations natin, you can actually select, no, any points sa beam, okay, and then you can actually solve for the ordinate of that point. Now, advantages yan pag yung load mo is, sinasabi na nandito, nandyan, so, maganda to. But, yun nga, ang pangit dito, guys, is you'll need to derive an equation. Now, in this case, ito. Now, siguro, sa tingin nyo, madali man lang i-derive ang equation, sir. Yes, madali, kasi madali lang yung beam. Diba? Ganun lang tayo. Madali yung example, mahirap yung exams, diba? So, anyway, ang mangyayari, guys, is, I think mas maganda, if ever ba, ang method na gagamitin natin is yung kabila lang. Okay? Yung una, at specific points lang. Kesa dito kasi, maliban lang, of course, no, kung hahanapin talaga yung equation, like sa problem is, solve using a influence line equation. So, wala kang magagawa. Yan talaga. But, if you'll try to choose, no, between the two, piliin mo yung una kasi mas madali. Okay? We have, just select specific points and then solve for the reaction, shear, moment using statics. Anyway, so I think naintindihan nyo, no? Let's try to solve another problem, guys, daw. Para mas ma-appreciate nyo. So, anyway, tapos na tayo, no? Nakita nyo yung paano yung reaction. Now, let's check daw pag shear naman yung hinahanap. By the way, guys, ito yun, ha? Yan, solution using tabulated values. So, yan. Ay, sorry. By the way, guys, I'm actually using OBS na software. So, by the way, meron akong dalawang scenes. So, ito yung, ang first scene, yan, yung makikita nyo. That is actually yung lecture scene ko. And then, yung next scene, yan, that is actually yung solution kung paano ko sinusolve yung problems. So, kung mapapansin nyo, minsan hindi ko na switch yung scene. So, please, tawagin nyo yung attention ko, like, okay? I-call nyo ba? Sir, scene 2, sir. Scene 1, sir. Ganun. Okay? So, anyway, guys, dito sa scene 1, yan. So, ito na. Yan, ha? So, this is actually solution using tabulated values. And then, we have the solution using, yan, influence line equations. And then, our equation for the reaction at AY is actually 1 minus 10x. Okay? Now, let's solve another problem. Napakadali ng problem na to. Hanap tayo ng iba. Yan, Now, this time, shear naman. Okay na kayo sa reaction. Now, construct daw the influence line for the shear at point C of the beam. Now, ito yung maganda, guys, kasi ang shear kasi along C or at any point dyan, along C, at point C is actually discontinuous. You cannot actually create one function, okay? One equation para sa shear at C. Kasi mag-iiba kasi ang shear, okay, dyan sa C, if ang load mo is before or after sa C. Papakita ko sa inyo later, ha? Papakita ko. Anyway, spoiler. So, check natin dito. By the way, guys, I hope na intindihan nyo yung problem kanina. Okay lang? Thumbs up daw if naintindihan lang. Naintindihan lang ba yung problem 1? Okay. So, let's proceed sa example problem 2. Now, sa example problem 2, guys, let's try to construct the influence line for the shear at point C of the beam. Now, pag hinahanap natin, guys, is shear or moment, we will actually use, kasi kailangan natin yung shear dito sa C. Now, baka nasanay kayo dati na find the shear at point B. Find the shear at point C. And then, ang gagawin niyo, naalala niyo, during sa strength of materials niyo, ang gagawin niyo is you will try to draw the shear and moment diagram. Okay? And then, from the shear and moment diagram, doon nyo na makikita kung ano yung shear sa C. Okay? Now, in this case, guys, hindi natin gagawin yan. Bakit? Ganito yung mangyayari. Yan, o. Pag, for example, meron tayong ganyan, o. Okay, meron tayong load, and then, tapos, halimbawa, nandito yung 1.0. Okay, and then you are actually interested sa shear sa C. Okay, you are actually, you will try to solve for the shear at C. So, ang gagawin mo, guys, since ito yung natutunan mo dati, so, to solve for the shear at C, you will actually create the shear diagram. So, ang gagawin mo, solve ka pa sa 0.5, 0.5, and then, create the shear diagram. Okay, so, taas, and then bababa na naman, and then ganun, and then ganun. And then you can actually look at C, tapos i-project mo yan, and then, uy, ang C, so VC is actually 0.5. Ganun. Okay, so, wag na guys, matatagalan na tayo niyan. So, to solve, actually guys, to solve for the shear at C, yung shear na yan, or yung moment sa C, actually mga internal forces man yan. Okay, nandyan sa C at saka, yan yung moment. So, to solve for that guys, we will be using method of sections. Okay? So, sa method of section, guys, simply cut the beam, or yun nga, natutunan nyo, di ba, yung method of section sa truss. Actually, you can use this dito din. So, cut the beam, guys, and then pag cut mo sa beam, maglalabasan na yung internal shear and moment dyan. Okay? So, if I'll try to solve for the shear at C, dito, from our problem, so, I will actually cut the beam dito din sa C. Okay? So, pag i-cut ko yung beam na yan, dyan sa C, ang mangyayari, guys, ito. Uy, bakit may 0.5 dyan? Wala pa yan. Okay? So, yan yung beam na mangyayari dyan. Now, huwag niyong kalimutan, since nag-cut ka, maglalabasan yung mga internal forces. So, meron kang shear dito. Meron kang shear dyan. Okay? And then, meron ka ding moment dyan. Now, before you can actually solve this mga problem na ito, no, sa shear and moment, please take note, guys. This is very important din. Kung ano yung direction ng shear. Okay? Kung ano yung direction ng mga shear dito. Now, gaya ng tinuro nyo sa strength of materials niyo, hindi dahil pababa yung shear, okay, yung direction. Notice na this is actually my shear sa C at saka moment sa C. Now, hindi dahil yung VC is actually going down, okay, not because it's going down negative agad, hindi. Okay, depende yan actually sa rotation ng beam. Kung kailan mo masasabing ang shear is positive or ang shear is negative. Okay, paano ba yan? Now, for example, guys, ito. Yan. Okay? So, itong shear na yan, VC, di ba? Yan yung shear VC. Now, how will that rotate the beam? Okay? Depende kasi yan sa pag-rotate ng beam. Now, notice guys that the beam will actually rotate, no? Clockwise, di ba? Mag-rotate yan pag ganun. Okay? Kasi it will, pag subjected ba sa shear na yan, okay? Yung free body na yan, di ba? Mag-rotate yan. Dahil nga, clockwise kasi yung rotation natin sa VC. Therefore, VC is actually a positive shear. Okay? Careful kayo niyan, guys, ha? Dapat, guys, ang assumption natin is actually dapat positive. Likewise din ang moment. For example, moment. Sir, kailan mo masasabi, sir, na positive ang moment? Now, again, hindi dahil clockwise or counterclockwise. Hindi. Dahil yan sa bending. Okay? Pag ang bending positive, therefore, that moment is positive. Pag ang bending negative, then that moment is negative. Regardless of the direction of the rotation, kung clockwise ba yan o counterclockwise ba yan. Now, paano ba natin malalaman yan? Now, ang positive bending, gaya ng tinuro ko no, sa mga students ko, is actually yan. Mag-smile ang beam mo kasi nga positive, di ba? Happy. Yan yung bending pag positive. Now, the negative bending, yun nga negative, so nag-sad ang beam. Now, kailan mangyayari ang bending na yan? Okay? So, mangyayari ang bending na yan pag ang moment mo is ganito yung directions. Yan, no? Di ba? Would you agree? Okay? Pag ganyan yung directions ng beam mo, okay, I mean, ng bending mo, yan yung mangyayari na bending. Pwedeng positive, pwedeng negative. Now, take a look at my moment sa C. Tingnan nyo yung moment sa C dito. Yan. Uy, napakit na wala. Check nyo yung moment sa C. Di ba positive yung bending ko? Even though counterclockwise siya, baka kasi isipin nyo na clockwise positive, counterclockwise negative. Hindi. Okay? Then yung MC ko actually is positive kasi nga clockwise yung bending. Clockwise yung bending. Nag-smile kasi yung beam. Okay? Tingnan nyo, nag-smile ang beam, oh. Yan. Okay, so nag-smile ang beam, positive. Sir, bakit mo nasabi? Di ba ito yung MC? Yan, oh. MC. Okay? Di ba yan yung MC natin? So, di ba, nag-smile ang beam dahil dyan. So, that is actually a positive bending. Again, guys, just chat nyo lang ha, if meron kayong tanong. So, anyway, by the way, guys, so, parang ito yung mukha, no? So, yung tinuturo ko sa students ko is, try to memorize na lang, guys. If ever, mahirap talaga i-imagine yung rotation kasi meron talaga mga students, no, na mahirapan sa pag nag-rotate, ganun, clockwise ba or positive ang bending. Ang sinasabi ko na lang is ganito. If you will try to consider, okay, the left section, okay, to have a positive shear dito sa cut mo, dapat going down yan and then yung rotation is counterclockwise. Now, likewise, actually guys, since this is method of sections, you can actually consider the other section or the other section. Okay, depende sa inyo. So, if you will try to consider this section, ito naman yung i-consider mo section, no problem, same pa rin yung makukuha mo, but remember na dapat yung directions, again, sorry if hindi drawn to scale, yung direction ng moment no is ganito. And then the shear, sandali. Medyo nagkadikit. Yan no? That is the shear and this is actually the moment sa C. Bakit? Okay? Those are actually positive moments and positive shear. Ha? Importante yan guys kasi magmamatter kasi guys yung values natin kung negative ba o positive sa solution natin. Okay? So anyway, once alam mo na no, kung paano mag-cut and then paano yung drawing mo sa shear and saka sa moment, okay, let's try to solve. Okay, the shear and the moment. So same pa rin guys, gagawa ako ng table. Okay? Now sa table guys, same pa din. Kung hindi mo pa, kung medyo kung medyo hindi ka pa marunong, no? Especially sa mga students natin na medyo hindi pa kayo marunong. So by the way, this is X and then I'm actually trying to solve for the shear no at C. So this is actually now my VC. Okay? So same pa din guys, gawa tayo ng mga specific points no sa point C. Sa C, so sa beam natin. So 0 and then quarter point no 0, 2.5. Okay? 2.5 and then until 0.75. By the way guys, important thing no, gaya ng sabi ko na shear is actually discontinuous no sa point C or kung saan tayo naghati. Ang mangyayari guys, dalawa pala yung 2.5 mo. Okay? Meron kang before 2.5, so 2.5 negative na lang, ganun. Meron kang before 2.5, ilalagay mo dyan. Hindi talaga siya parang nasa 2.5 na siya, but before lang. Okay? Hindi siya lumagpas sa cut natin. Okay? Parang ang nangyari guys, ganito. Okay? Diba, dito tayo nag-cut. Siguro nandito siya, yan. Yan, nandyan sa yung 1.0 natin. Okay? And the other one is after 2.5. Okay? So, 2.5 plus. Now, sir, always ba na 2.5? Depende. It so happen kasi na yung C natin is nandun sa 2.5. So, kung nandyan yan sa 5, meaning, yung 2.5 isa lang. But yung 5 mo, meron kang before 5 and after 5. Okay? So anyway, before 2.5, after 2.5, and then we have 5, and then 7.5, and lastly, we have our 10. Yan. Okay? So, anong gagawin natin guys? Now, we will try to solve VC for every location of that point load. So, sige guys, i-drawing ko na ulit. So, see, napakatagal nito, but tingnan nyo, yung third method natin, very easy. Okay? So, I'll try to solve for the VC at if ang unit load natin is actually at 0. Okay? So, na-solve natin to kanina, di ba? I think na-solve natin to. So, this is actually 1.0 din. Okay? So, I will cut dito. Ika-cut ko. Yan. Okay? So, ano yung gusto nyo? Oh, by the way, this is actually 0. Ano yung gusto nyo i-consider? Yung left or yung right section? Okay, I think mas maganda, no? Pag, anyway, pwedeng left na lang. Okay, so, left section, I'll try to consider the left section. So, ganyan, no? 1.0. So, this is 1.0. So, again, the shear is going down if you'll try to consider the left section to have a positive shear. Again, bakit? Kasi clockwise yung rotation. So, this is actually VC. And then, we have the moment MC. Now, I'm not interested sa moment. I'm interested sa shear. Okay, so I'll just sum up forces. Vertical is equal to 0. Upward equals downward. Okay, so ano yung upward forces natin? So, ano yung upward natin dyan? So, 1.0, no? Okay? And then that must be equal to the downward forces. Okay, so, ano yung downward natin dyan? So, that is actually equal to 1.0 plus VC. Agree kayo dyan? Okay? I hope agree ba kayo? Okay? No? Tingnan nyo. By the way, ito yung free body diagram na tinutukoy ko. Huwag nyo pansinin to. Huwag nyo nang pansinin to. Wala na to. Okay? You will consider this. Yan. So, agree lang kayo dito na ang VC daw is actually equal to 0. Cancel out. Agree? Okay lang? Okay. So, I will try to, so, 0 na to. Yan. 0. So, again, wala na namang silbi to. So, circa, ang haba. So, wala kang magagawa. Wala pa kasi tayo sa third method. Yan. So, wala na namang silbi to. Yan. Buburahin ko na naman. Ito. Yan. Tapos, ilalagay ko na naman. Uy, tingnan nyo. Dalawa. Yan. Dalawa yung 2.5 natin. Okay. So, before and after. So, I will actually put the load before muna. Before kasi, una kasi yung before dyan. So, ang mangyayari guys is, still, nandyan yan sa 2.5. Yan. So, 1.0. So, 2.5, 7.5. Okay? Ay, hindi pala 1.0. Okay, now, let's try to solve guys sa reaction. Okay? So, na-solve din natin to kanina, di ba? Same lang to. This is actually 0.75. Now, this is actually 0.25. Okay lang? I hope na okay tayo ha. Na-solve natin yan kanina. Okay? I hope okay tayo sa reactions. Hindi kasi tayo interesado sa reaction for now. Okay? So, same pa rin. I will try to cut. Okay? So, ang cut ko guys is ganito. If this is 0.75, now, itong load ko, nandyan. 1.0, 2.5. So, again, the shear is going down. VC. Yan. MC. Okay lang. Okay lang, naintindihan ninyo yung pag-cut. Tingnan nyo. Nag-cut ako, okay, yung load ko na 1.0 is actually na before sa 2.5. But, anyway, nandyan pa din siya sa 2.5, guys. But, nandyan na siya before lang kasi meron kasi tayong point dyan. Meron kasi tayong point na consider. Okay? So, since that is before the 2.5, before the 2.5, if I will try to sum up forces, okay, dito ko na lang ilalagay. Summing up forces vertical is equal to 0. Upward is equals downward. So, ano yung upward forces ko dyan? Okay? Ang upward forces ko is obviously itong 0.75. Okay? Yan yung upward forces ko, no? Meron pa ba iba? Wala na, no? And then that must be equal to the downward forces. Ano yung downward forces natin? 1.0 and then plus VC. Okay? Therefore, solving for VC, we can actually solve no VC is simply equal to negative 0.25. Therefore, negative pala ang shear. Okay? Negative kasi mali yung assumption natin. Nag-assume tayo guys na positive ang shear, di ba? Tingnan nyo, nag-assume tayo dito na positive ang shear. Negative yung sagot. Now, that doesn't mean na mali yung sagot mo. Mali lang yung assumption mo. Okay? So, therefore, your assumption, so, since positive yung assumption mo, negative yung sagot, mali yung assumption mo, so, negative shear. So, anyway, negative 0.25. Yan. Okay? Naintindihan ninyo? Tingnan nyo. Bakit, sir? Bakit ganun, sir? Bakit dalawa yung 2.5? Tingnan nyo, papakita ko ha. What if, okay, yung 1.0 is nandito na after, okay? So, buburahin ko muna to. Okay? Nandito na siya after sa point 2.5. So, ang mangyayari guys, bali, nandito na yung, idodraw ko yung kabilang section. Okay? So, sa kabilang section guys, VC. And, so, nandito actually yung 1.0. Okay? Nandyan yung 1.0. So, sir, paano yan, sir? Pag nandyan yung 1.0, sir, ano yung gagawin natin, sir? Ano yung i-consider namin? Yung left ba, sir? Or yung right pa din na section? Now, actually, depende yan sa inyo, but still, same pa din ang sagot. Okay? Tingnan nyo ha. I will try to consider this section. Okay? Pag nag-consider ako dyan, summation of forces vertical is equal to 0. Upward is equals downward. Ano yung upward forces? 0.75. Diba? Ano yung downward forces? Now, the downward forces, obviously, we have, VC. Tama ba? Tama, VC. O, yan na yung sagot mo. VC is equal to 0.75. Okay? Now, let's check daw, considering the left section, let's try to check kung tama ba. Okay? So, summation of forces vertical is equal to 0 pa din. Upward is equals downward. Ano yung upward forces? VC plus 0.25. Okay? Ano yung downward forces? Okay? The downward forces, obviously, 1.0 lang ang natira. Okay? So, meaning, VC is actually 0.75. Both are positive, meaning both are positive values. Therefore, tama yung assumptions natin. And then, from our figure, we assumed a positive share. Therefore, ang sagot pala dito, guys, is positive 0.75. Tingnan nyo, di ba? Nag-matter, di ba? Tingnan nyo, nag-matter. Yung isa negative, yung isa positive. Okay, tapos iba pa yung magnitude. Yung isa 0.25, yung isa naman is 0.25. Okay, so importante yan, guys, ha? Importante yan. So anyway, guys, again, wala na namang silbi to. Buburahin na naman natin. Ha? Burahin natin, ha? Wala na silbi to. Yan. Okay? And then, likewise, ito din, wala na din. Yan, bura-bura. Yan. Okay? So, ilalagay ko na naman yung load, okay, sa 5. Okay, same pa din, ilalagay ko sa 5. Okay? But, baka isipin nyo, dyan ako sa 5 mag-cut. Hindi, sa C pa din ako magka-cut. Always yan sa C. Okay? So, bakit 5 yan? Okay, so this is actually 1.0. And then, 0.5, 0.5. Again, okay, pag hindi mo alam, 0.5 dyan, naku po, no? So, this is actually 5 feet, no? Tama ba? 5 feet ba? Tama. And then, 5 feet din sa kabila. Okay, so, I think okay na tayo dyan, no? 0.5, 0.5. So, ang gagawin ko, guys, I will cut here. Yan, kakat ko. So, I think mas madali consider yung left pa din. So, yan, 0.5, and then we have, yan, VC and MC. Okay? So, same pa din, guys. I'll just summing up forces, vertical is equal to 0. Upward is equals downward. Okay? Upward is equals downward. So, ang upward force natin, ano ba? VC, no? So, 0.5. 0.5 pala yung upward. And then, the downward force is actually VC. Therefore, wala nang iba yan. VC is actually positive 0.5. Yan na. Di ba madali na? 0.5. Okay? Now, again, bura. Lipat na naman natin dito sa 0.75 yung load. So, I think naburingan na kayo, no? Kasi, sir, ba't ang dali? Madali lang talaga i-solve ang problem. Kasi nga, madali lang, but medyo matagal. Okay, now sa board exam, wag mo nang gawin to, promise. Pag ito yung ginawa mo sa board exam, na, wala na. Finish ka na kasi gumawa ka pa nito. Okay, don't worry, guys. Yung next method actually maganda. Okay, so this is 1.0, no? Nasa 7.5, tama ba? Tama. So na-solve din natin yan kanina. So this is actually 0.75, and then ito naman is 0.25. Okay? Same din, cut tayo dito, cut tayo dyan, and then ang mangyayari, yan, 0.25 going down na VC. Okay, and then MC. So, VC is obviously equal to 0.25 na lang. Okay? So, downward is equals upward. So, this is actually 0.25. Okay? And then, likewise, pag ilalagay natin yung unit load dito, sa edge talaga, okay? Sa edge na yan, so, magiging 1.0. Therefore, ito, 1.0 to. And then, ito, 0 din. So, kung 0 yan, okay. Therefore, ang shear natin dito is actually 0 din. Okay? So, pag ang unit load nasa 10, 0 pala. Yan. So, after that very tedious, no, na process, ang gagawin natin is plot the points. Okay? So, again, burahin ko na naman, guys. So, bura-bura na naman. Uy, sorry. Yan, burahin ko na naman. So, plot ko ang points, guys. The first point is at 0, 0. So, ito yun. Okay? By the way, this is our x-axis, the length of the beam, and then we have the VC. And then, ang next point is actually sa 2.5, okay? And then we have negative 0.25. So, I hope agree kayo. So, since negative, nasa ibaba yan. So, this is actually, yan. Ganito na lang yung, sorry. Yan, so, dito, no? Tama ba? Ay, sorry. Yan pala. Okay? So, itong point na to, this is actually 2.5. negative 0.25. Yan. Now, the other point is, kung mapapansin nyo, nandito, no? Agree ba kayo? Nandito yung other point natin, yan. Okay, so yung other point natin, nandyan sa 2.5 din, but positive na 0.75. Okay? Excuse me. And then yung next natin is nandun sa 5, but nasa 0.5, so mga nandito na siguro. And then yung next is nandito. And then last is nandito. Now, agree kayo sa mga location ng points? Thumbs up daw if okay lang. Okay, okay. So, since agree kayo no, sa location ng points, okay, akala ko kasi wala nang nakikinig. Ay, salamat, no? Okay. So, anyway, I'll just connect the points, okay? So, connect ko yung points, ha? Going down. Oh, by the way, pag nag-connect kayo ng points, huwag baka ganito yung pagka-connect nyo, ha? Hindi. Huwag. I-follow niyo yung order ng points, okay? Ay, hala. Na pala. Just try to follow no, the order of the, yung bang ordinates natin. So, I mean, yung points na nakuha natin. So, 0, and then before, after, and then going down. Yan. Okay? So, yan na, guys. Okay? Yan na yung influence diagram mo. Okay? For the shear at C. So, meron na. Okay? So, yan na, guys. So, let's try to solve daw itong problem to using the other method, yung influence, anong tawag dun, yung equations ba. Okay? So, buburahin ko to, ha? Buburahin ko to. Yan. So, paano ba to? Buburahin ko na lang. Okay, don't worry guys, yung mga solutions ito, kasali din kasi sa, anyway, meron kayong video, this is actually recorded, you know, don't worry, ipopost ko din to sa YouTube channel ko. By the way, try to subscribe ha sa YouTube channel natin. Meron akong advertisement si sir. Meron akong mga lecture video sa theory if ever nahihirapan kayo sa theory. So, buburahin ko muna to. Yan. So, ang gagawin ko guys, same pa din. I will try to cut the beam, but this time I will place the load at a variable point, no, within the beam. Now, kung mapapansin nyo kanina, kung mapapansin nyo kanina, yung shear natin, yan, di ba ganito, no? Shear is actually discontinuous sa C, since we are actually considering point C. Ano yung discontinuous? Notice na ang equation ng line na to is ganito. Ang equation dito is ganyan. Although same sila, hindi sila, naputol sila dito, naputol sila dyan, no? Naputol sila dyan. So, you actually need two equations for this. Now, paano natin gagawin yung two equations, sir? Simple lang, no? Ang gagawin mo lang is ito. Putulin mo yung beam. Yan. Ilagay mo yung X, or ilagay mo yung unit load before and after din. So, for example, the first equation, ito yung gagamitin mo. Yan. Nandyan siguro yung load. Okay? And then the second equation, ito yung gagamitin mo. Nandito na siguro yung load na 1.0. Yan. But at variable, okay? Variable X. Okay? So anyway, let's try to solve, guys. First, I'll try to check na. Ilalagay ko muna dito yung load na 1.0. Oh, by the way, burahin ko muna to. Ay, tama. Okay lang pala. 0.7.5 pala. Now, by the way guys, before pala kayo, again ha, before kayo mag-cut dyan, before kayo mag-method of sections, kung ano ba yan, try to solve muna yung external forces. Now, ito, if you will try to consider the left section, kailangan kasi natin yung reaction sa left. Okay, so anyway, tawagin natin tong AY, and then this is actually, since hindi natin alam ha, kung ano yung distance yan, basta before siya sa cut, okay, since hindi natin alam, so tawagin muna natin X. Okay, so ang mangyayari guys, yan. Ay, sorry. AY, and then, paano ba to? X 1.0, and then this is actually 2.5. So, ang shear natin dito is, nandyan no, VC. Uy, by the way, hindi na pala, paano ba to? Magmamatter ba dito? Okay. So, sorry, nakalimutan ko. I-solve pa pala natin no, yung AY. So, anyway, I'll try to sum up moments dito sa B. Okay, summation of moments at B is equal to 0. Clockwise is equals counterclockwise. So, ano yung clockwise moments natin? We have AY times 10. Okay? That must be equal to the counterclockwise moments na 1.0. Okay? Times, I think same to sa kanina, no? Na sinolve natin. 10 minus x. So ay is actually equal to paano ba yan? Ay is equal to 1 minus x over 10. By the way guys, if may napansin kayong mali sa equation ko, please call my attention. Again, mahirap mag-solve while nagsasalita. Okay, so anyway, yan. So since meron na tayong ay, you can actually, yan. So ito yung VC, no? VC, and then we have the 1.0 here. Yan, and then this is actually the x. And then this, ano to? Ano nga ulit to? 1 minus x over 10. Okay? So, summing up forces vertical is equal to 0. Upward is equals downward. Okay? Ano yung forces upward? The forces upward are 1 minus x over 10. Okay? And then, meron pa ba iba? Wala na, no? So, that must be equal to, okay, 1 plus VC. Okay? Tama, no? So, with that, we can actually solve our, we can actually solve VC. Okay? So, cancel out yung 1 dito. VC is actually equal to negative x over 10. Okay? Yan yung equation natin before the cut. Now, let's try to solve the equation after the cut. Okay? So, ano yung after the cut, sir? Same pa din. We'll try to consider this. Okay? Same pa din yung beam natin, guys. Same pa din. Yan pa din yung beam natin. But this time, okay, ito yung cut, no? Ito yung cut natin. So, ilalagay ko na lang dito yung 1.0. Okay? We have the x. Yan. Ito pa din yung x value natin. Uy, bakit pumapangit na yung penmanship mo, sir? Yan. Yan yung x natin. So, again, guys, bakit makaisipin nyo, nagbago yung ay. Hindi nagbago ang ay, ha? Ay is still the same. 1 minus x over 10. Hindi magbabago yan kasi yung moment arm dito, still 10 minus x, di ba? Hindi magbabago yan. Nagbago lang yung dyan. Pero yung figure natin nagbago lang, but hindi nagbago yan. Now, let's try to solve naman yung shear, no? I-cut natin tapos yung point load is nandun na sa after na sa cut. So, parang ganito yung mangyayari. So, 1 minus x over 10. Tama ba? Sandali. Yan. So, this is 1 minus x over 10. So, ito, paano ba to? Downward, no? Tama? Yan, downward, VC. Okay, and then yung moment, anyway, di tayo makikialam dyan. So, sir, asan yung point load? By the way, this is 2.5. Sir, asan yung point load? Yun nga, I try to consider, no, yung left side. Yung point load nasa kabila. Huwag mo nang pakialaman. Ha? Nandun sa kabila. Huwag mo nang pakialaman. Okay? So, anyway, summation of forces vertical is equal to 0. Upward is equals downward. Okay? So, the upward forces, 1 minus x over 10. Likewise, the downward force, likewise, our downward force is actually VC. Therefore, yan na. Yan yung VC mo. VC is actually 1 minus x over 10. So, you have your two equations. Then, you can now draw your influence diagram. Okay? So, draw down natin dito sa kabila, ben. Draw down natin. Now, Now, take note, guys. Itong equation na yan, baka kasi itong negative x minus 10, gamitin niyo yan sa kabila. Hindi. Dapat yung x values mo dyan is from 0, okay, to, okay, from 0 to 4, ayun, ano nga yun? 2.5 no? From 0 to 2.5 lang. Okay? Kasi yan yung length ng cut na ginamit natin, di ba? 2.5 kasi to. Okay? Likewise, okay, ang x din dito, okay. Tama. Likewise, ang x dito, guys, okay, although, tingnan nyo, although ang cut natin, okay, is nandito, no? Ito yung kinonsider natin. Ang x natin will actually move, tingnan nyo ha, ang x natin will actually move, sandali, yan, from 2.5 to 10. Check down natin, ba? Hindi ko to na-try na. Okay? Actually, guys, kanina ko lang na-prepare yung handouts natin. Medyo nagka-problema kasi alam ng mga theory students ko yung situation namin dito sa kisame namin. Anyway, check natin dito daw. So, ang x mo dyan, that must be from 2.5, okay, to 10 lang. Okay, let's try to check daw pag same ba tayo ng values dito. Sandali lang ha. Kasi I think medyo may mali dito. Check ko lang ha. Anyway, check natin yung first value natin, guys. Yung at x is equal to 0, and then from negative x over, sorry, ano pala, negative x over 10. So, check down natin dito. Negative x over 10. So, pag ang x is equal to 0, 0 din yung shear natin. So, check down natin. Uy, nabura ko na, no? So, anyway, pag ang x daw is equal to 0, 0 ang shear. Naalala nyo pa yung kanina, yung dinraw natin? Nandito ba sa kabila? Wala na, no? So, anyway, yung values natin, medyo naalala ko pa, no? So, parang ganito yung value natin. Sandali ha, i-drawing ko. We have x, and then we have the, ano yun? VC. Sandali ha. So, this is actually now 0. So, I think 0 din yun. Ito, 2.5, but before 2.5, so ang nakuha natin dito is actually negative 0.25. And then dito is, sorry, ano nangyari? Okay. Hello? Naririnig niyo ako? Hello? Okay. So, 2.5, tapos after, okay, salamat. May nag-click kasi akala ko kung ano. So 2.5, so this is actually positive 0.75, and then pag 5 yan, and then pag 7.5, this is 0.25, and then pag 10, this is actually 0. Okay, I think tama lang pala yung equation, kinabahan ako guys. Anyway, pag x is equal to 0, tama na, tinan nyo sa calculator ha. Pag x is equal to 0, ang, yan, so, negative, ay salamat, may nag-take note pala. Okay. So, pag x is equal to 0, tinan nyo, 0 din yung answer natin, which is tama, di ba? Tama tayo, pasok tayo dyan. Now, pag ang x is equal to 2.5, but be careful, you need to use the function na before 2.5. So, yung function natin is ito. So, calculate 2.5, tinan nyo yung sagot natin. Negative 0.25, uy, pasok pa din tayo. Diba? Now, yung negative x over 10 mo, you cannot actually use that. Hindi mo na pwedeng gamitin yan, okay, sa susunod na mga values. Bakit? Kasi this is actually, itong mga values na to, ang unit load mo dyan, lumagpas na sa kabila. Okay? You cannot use that equation. So, ang gagamitin mong equation, guys, is ito na. Yan. Check down natin. So, pray natin, no, na tama yung sagot ko. 1 minus x over 10. Okay? So, pag ang x naman is 2.5, ay, salamat. Okay? So, positive 0.75. Okay? And then, pag 5, yan. 0.5. Okay? And then, pag 7.5, yan, 0.25. And then, pag 10, ay, salamat. Kinabahan ako. Okay? So, 0. So, anyway, see? Same lang din, and then I know na alam niyo na kung ano yung gagawin after, di ba? You will plot the points and then connect the dots. Now, guys, itong method na to, guys, trust me, no? Walang gagamit sa method na to. Walang gagamit sa method, ay, sorry. Yan. Ay, sorry, again, hindi ko na change slide, sorry. Yan, sorry, hindi ko na change slide, sorry. Walang gagamit, trust me, guys, walang gagamit sa method na to during sa board exam. Kung gagamit ka sa method na to, good luck, no? Good luck sa iyo. Okay? So, ang gagamitin natin, guys, is ibang method. But I think meron pa tayong, tapos na tayo sa reaction shear. Let's check muna yung moment. Moment muna. Last problem is itong moment, and then ituturo ko na yung isang method. Okay? So, anyway, let's try to check itong last problem. Yan. So, I hope naintindihan niyo kung paano natin i-solve yun. Now, this time, guys, let's try to calculate let's try to construct the influence line for the moment at point C. So again, guys, ang ginagawa natin so far, no, is we are actually trying to draw, okay? To draw the influence lines, okay, of our beams for a specific point. Okay, shear, moment, or reaction man yan. Now, at least makita nyo lang, no, kung ano yung itsura ng shear, moment, at saka reaction. So let's try to solve muna sa moment, guys. Okay? Now, sa moment, balik tayo dito. Yan. Now, ito yung beam ko, no? Ito maganda kasi meron tayong overhang. At least makita niyo yung itsura niya. Yan. So, construct the influence line for the moment at point C of the beam. Okay? Point C of the beam. So, asan yung point C dito? Nandito, no? 4, 4, and then we have 4M. Okay, 4M. 4M. Okay? So, ang gagawin natin, guys, construct the influence line for the moment at point C of the beam. Tama. Okay, so same pa din, guys. Select tayo, no? Isa na lang yung method na gagamitin ko, ha, para medyo mas madali tayo kasi 580 na kasi. Okay? So anyway, ang gagawin ko is yun nga yung specific points na lang, okay, sa beam. So I'll try to draw dito. Okay. By the way, guys, same pa din, guys, ha? Ika-cut natin to dito. Okay, same pa din. And then try to solve for the moment there, depende kung saan yung location ng point load. So ilalagay ko na naman ito. Yan. Ay, sorry guys, ang pangit ng line. Diba? Ni-straight na. Yan. So, this is X, and then this is my moment at C. So, same pa rin guys, 0. Ito kasi yung 0, 4, 8, and 12. Yan na lang yung i-consider ko guys. Tingnan nyo. 0, 4, 8, and 12. Tama, no? Okay, 0, 4, 8, and 12. So, I think okay man lang. Kasi hindi naman mag-matter ata yung yeah. Anyway, so check down natin dito. Yan. First, I'll try to solve for the moment. For the moment, if at C, if the point load, sorry guys, 4, and then 4, 4. Okay, if ang point load is nandito sa 0, okay? Or sa leftmost. So, pag 1.0 yan, obviously, this is, again, 1.0, and then this is actually 0. Okay? So, if I will cut the beam here, so, ang mangyayari dyan, meron kang parang ganito. Okay? So, again, I'm not interested sa shear, di ba? So, anyway, moment na lang yung ilalagay ko. Okay? So, meron ako moment dyan, MC. Again, guys, uulitin ko, when you try to draw the moment there, dapat positive ang moment na ilalagay mo. Okay, so ano yung moment na yan? Positive. Hindi dahil counterclockwise or clockwise, kundi, yun nga, mag-smile ang beam because of that bending. Okay, so since positive yan, so I'll just sum up moment at C is equal to 0. Clockwise is equal to counterclockwise. Equilibrium, ha? So, clockwise is, 4 to, no? Yan. So, 1 times 4. Yan ang ata yung clockwise, no? And then the counterclockwise is actually equal to MC plus 1 times 4. Okay, now obviously MC is equal to 0. Tama ba? I think tama, no? Tama. MC is now equal to 0. So, lalagay ko to dito. Excuse me guys, excuse me lang ha, may inom akong tubig. Okay? Balik ta. So, with that, okay, after nyan, nakuha na natin na 0 ang moment, 0 ang moment sa MC. Okay, naririnig nyo ako? I hope okay lang, naririnig nyo pa din ako? Test, mic test. I think okay lang. Okay, sige. So, the moment at MC is equal to 0. So, 0 yan, di ba? Now, this time guys, ilalagay ko na naman yung unit load, okay? Ilalagay ko na naman yung unit load dito sa, saan ba? Sa 4, no? So, buburahin ko na naman to. Yan. So, nandyan yung unit load, 1.0. So, obviously, yung reactions dito is 0.5, and then this is actually 0.5. Okay? So, ano nangyari doon? Sorry. Nagre-record kasi ako, so medyo may something na nangyari. Anyway, clockwise is still equal to counterclockwise, but I think obvious naman no, na 0.5 yung reactions dyan. So, depende na sa inyo kung i-check nyo pa din. Okay? So, with that guys, let's try to check down ito. Yeah. So, ang gagawin ko, paano ba to? Dito na lang, no? Ika-cut ko dito pa din, dito. Pag nag-cut kayo dyan guys, it won't matter guys kung before or after ba. Bakit? Moment kasi yan, and then ang kailangan natin is moment arm kasi. Now, the moment arm, pag before and after is very small pa din. So, actually, yung 1.0 manineglect lang. Okay, so what will rotate, obviously, is the 0.5. Okay, ano? What will rotate is the 0.5. So, ito yung M natin. By the way, this is 4, and then this is actually MC. So, summation of moment at C is equal to 0. Clockwise is equals counterclockwise. So, clockwise moment. Uy, ano yung clockwise moment natin dito? Tama. Meron na. 0.5 times 4. Tama ba? Clockwise. Tama? And then, that must be equal to MC. Now, with that, obviously, no, MC is equal to 2.0. Okay? MC is equal to 2.0. So, ilagay natin dito 2.0. Okay? Now, let's move on. Ilipat natin to. Ito. Bura-bura na naman. See? Napakatagal. Wag nyo gawin to, please. But anyway, sa plates ninyo, kailangan nyo itong gawin, ha? Sa mga students ko dyan. Ibang-iba. One problem for every method na lang yung ibibigay ko para hindi kayo medyo mahirapan, ha? So, shout out sa CE361. So, 1.0 ilalagay ko dyan. CE361M4, no? So, ito, nandito. Yan, 1.0. Okay? And then, after nyan, so, okay, akala ko may tanong. Anyway, so, ang gagawin natin, guys, paano ba to? Ikakat ko dito, no? So, obvious naman ata no na, since wala tayong reaction dyan, wala din natang moment na mangyayari dyan, di ba? So, automatic, 0 na yan. Okay. Now, let's try to solve pag ang 1.0 ilagay natin sa edge. Okay? So, ilagay natin sa edge. Yan. Okay? So, sum up ako ng moment. Paano ba to? By the way, pag naglagay ako sa edge, no? So, paano ba to? Ito na lang i-consider ko siguro. Ito. Dito. So, I'll try to solve for AY siguro, no? AY. Okay, so summation of moment at B. B ba yan? Tama? B is equal to 0. Clockwise is equals counterclockwise. So, the clockwise moments, ano yan? 1 times 4. Tama, no? And then, meron pang isa. Actually, yung AY, clockwise din yan. Bakit kaya clockwise din yan, no? Tama, no? With a moment arm of 8. Okay? So, that must be equal to, ano yung counterclockwise, guys? Marami nakikita na counter. Wala, no? Wala tayong counterclockwise. So, by the way, I'm summing up moments to be. So, this is actually equal to 0. Now, obviously, no? Ang AY natin is negative. Anong negative yan? 4 divided by 8, I think 0.5. Tama ba? So, negative, 1 times 4. Nasanay na tayo mag-shift solve, no? Kahit napakadali. But, at least na maniwala kayo na baka kasi hindi kayo maniwala. Negative 0.5. Actually, ako din. So, negative 0.5 yan. So, since negative 0.5 yan, obviously, again, hindi dahil negative ha, mali yung sagot mo. Negative means mali yung assumption mo. Anyway, gaya ng tinuturo ko sa mga students ko, do not change the direction of the loads. Okay? Just retain the sign. Negative 0.5. Huwag nyo nang pakialaman yung direction dyan. Mahihirapan lang kayo. Okay? So, anyway, upward and then negative 0.5. So, nag-cut ako na dito. And then, I have 4. And then, this is actually M. Okay, my moment MC. So, summing up moment at C is equal to 0. Clockwise is equals counterclockwise. So, ang clockwise moments ko, ano ba yung clockwise moments ko dyan? Yung negative 0.5, di ba? With a moment arm of 4. And then, yung counterclockwise moment ko is ito, equal to MC. Therefore, MC is actually equal to negative 2.0. Okay, so ilalagay ko dito negative 2.0. Now, from our ordinates, okay, by the way, yung mga 0, 2, 0, at saka negative 2, those are actually ordinates. With our ordinates, we can actually now plot the points and draw or connect the lines or the points. So, I think pwede na to, no? So, if this is X, gandahan natin. If this is X, MC, ano ba to? 0, 0, di ba? And then, 4, 20, ano yun? 4, 20, hindi, 4, 2.0. So, 4, dito na lang, dyan na lang. Okay, so 4, 8, 12. So, 4 is 2.0, so siguro nandito. And then, yung next is 8, 0, so nandito. And then, yung last is 12, negative 2, so nandito. So, anyway, draw natin yung moment diagram. Ganyan. Yan. Yan. So, yan na yung with ordinates na 2.0 and then 2.0. So, yan na yung influence diagram natin. Check na natin kung tama ba. Ay, sorry. Yep. So, yan ha. Yan yung influence diagram natin. Ay, sorry. Okay, so again guys, at least meron ako yung idea on how to create the influence diagram. Now, sa next part, anyway, 30 minutes na lang, meron na tayong 30 minutes, but don't worry, actually yung next part is, ito yung importante. Once meron ka ng once meron ka ng influence diagram, okay, you can actually now solve, no, with our influence diagram, okay, we are actually interested sa moving loads. We can actually predict, no, predict the location of the moving loads. Okay, from our influence diagram, we can actually predict, or we can know the location of the moving loads, so that we can actually solve the critical shear, critical moment, okay, dito sa C, okay, or critical reaction sa A, okay. By critical guys, I mean maximum, okay. As engineers, we are interested, no, sa maximum values kasi dapat hindi lalagpas dyan yung allowable natin, okay. So ang mangyayari guys, from our influence diagram, we can actually predict, okay, yung location ng loads. So, it is important, no, na alam natin yung influence diagrams natin. Provided na yung loading nga natin is yung mga moving loads. Now, ang next method, ituturo ko sa inyo ito, yung Mueller-Bristol method. Ito yung shortcut method natin. So, anyway, bibilisan ko lang ng konti kasi meron tayong 30 minutes. So, ang mangyayari guys, yan, sa method na to guys, instead of, kanina kasi notice na yung ginawa natin kanina, ordinate, and then draw the diagram. Diba? Kinuha natin yung mga ordinates, be it using the tabulated method or yung equation. Okay? Ordinate yung ginamit. Yun yung ginawa natin. Ordinates and then diagram. Now, in this method, guys, ang maganda dito is diagram yung una and then later na ang ordinates. Which is very, mas madali. Kasi sa ordinates, kasi pag meron ka na kasing diagram, madali na lang ang pag-solve sa ordinates. Kasi kanina kasi, depende kasi sa number of ordinates yung diagram mo. Okay? So, mahirapan. What if hindi mo alam na, uy, ito pala yung diagram. So, dapat marami kang ordinates na marami kang points na i-consider sa beam. Okay? So, medyo napakatagal talaga doon. Now, ito madali lang. Now, ito yung sinabi niya sa principle niya. Okay? So, sinabi niya na ang influence diagram daw sa shear, sa moment, or sa reaction is just similar, no? Is just similar pag, okay, para bang, ano pa yung term na ginamit niya dito? Tingnan natin ito. It states that the influence line for a function, reaction, shear, moment is to the same scale as the deflected shape of the beam when the beam is acted upon the function. Okay, same tayo yung deflected shape niya pag, okay, for example, reaction, edi, pag lagyan natin ng reaction dyan, sa beam, pag shear, lagyan natin ng shear doon sa point na yun. Pag moment, lagyan natin ng moment doon. Now, let's try to solve daw yung kanina, yung mga problems kanina using this method. Okay? So, the first problem, sana yun? Yan, yan pala. So, construct daw the influence diagram for that beam. So, ang gagawin natin guys is ito. Sabi niya, we will try to act, di ba? We are actually interested sa reaction sa A. So, ito yung tinuturo ko sa review. So, ang gagawin nyo guys, instead of solving yung napakataas na method, release point A. Or just, itong point A, i-release mo ba? I-consider mo na merong reaction na nilagay dito talaga sa point A. Okay, merong load dyan. And then, let the beam deflect. Now, actually, hindi naman talaga deflect. Parang, let the beam rotate na lang siguro yung term, no? Let the beam rotate or deflect. Anyway, yung term na ginamit niya is deflect. So, let the beam deflect. Now, how will the beam deflect with the force at A? Now, ito, pin kasi yan. So, hindi yan magdi-deflect itong point B. So, since we will try to push the beam upward at A, so the beam will actually rotate this way. Agree kayo dyan sa rotation ng beam? Thumbs up daw if agree kayo na ganyan yung pag i-push natin pataas sa A. Agree kayo na ganyan, di ba? So, yan na guys. Yan na agad. Yan na, ito na. Di ba? Oh, yan na. Yan na yung influence diagram mo para sa A. Now, yun nga, meron ka ng diagram, wala kang ordinate. Now, ito yung maganda. Okay? Dito, pag reaction or shear, kung saan ka nag-cut or kung saan ka nag-consider, dapat ang total niyan is 1. Ganun lang. Dapat ang total niyan is 1. Pag shear or reaction. So, therefore, this is actually equal to 1.0. Yan na. And then, again, linear na lang to. Line na lang yan. Wala nang problema. Yan na. Okay na. Yan na. Di ba? Wala na. Okay na. Na-draw mo na yung shear yan. Check na natin yung number 2. So, ang dali, sir. Bakit mo pa? Ay, sorry. Ayan, oh. Construct the influence line for the shear at point C. Okay, so, check ko yung, ay, sorry. Hindi ko na switch yung scene. Check ko yung point C. Construct the influence line sa point C. So, same pa din, guys. Ito dito. Ito yung beam natin. Yan yung beam. Okay, so, I'm interested sa shear at point C. So, ang gagawin ko, guys, cut the beam. Okay, cut the beam and then subject the beam by the functions itself na diba? So, since we are interested sa shear, i-subject natin to yung point C sa shear din. So, pag i-cut ko yung beam, yan, and then ito, i-cut ko din dito yung beam. So, and then I will subject yung point C to the shear. Okay, kasi shear kasi yung hinahanap. So, ano yung shear ulit? Ito, at saka dito, kabila, yan. Agree kayo? Diba yan yung sign natin kanina sa shear? Agree kayo? Okay. So, ang mangyayari, guys, is let the beam rotate or deflect. Now, how will that deflect or rotate? Di ba ganito? Ay, sorry. Naririnig nyo yung, sorry, hindi kasi, yung mic ko, ang ginagamit ko ng mic is actually yung tablet lang. Kaya medyo, wala pa akong noise cancellation. So, anyway, guys, yan na, automatic, yan na. sorry. So, automatic, yan na yung diagram. So, sir, pinahirapan mo pa kami, sir. Ikaw, sir, ha? No? Meron palang shortcut. Now, yun, di ba? Ay, sorry. Now, once meron ka na yan, guys, yun nga, gaya ng sabi ko, unfortunately, 2.5, 7.5. Wala tayong ordinates. Meron tayong diagrams, wala tayong ordinates. But, ito yung maganda, shear. Ano yung sinabi ko? Pag ang shear, kung saan ka nag-cut, 1.0 ang total. So, ibig sabihin, hindi ko alam to, so tawagin ko na lang itong Y1, and then ito Y2. Okay? So, pag i-add ko ang values ng Y1 at Y2, Y1 daw plus Y2 is actually equal to 1.0. Sir, dalawa ang equations ko, sir. Sinabi ng algebra teacher ko, sir, pag 2 ang, dalawa yung unknowns. Pag 2 ang unknowns ko, sir, 2 din dapat ang equation. Now, saan tayo hahanap, no? Matik na. Saan tayo hahanap ng secondary equations? Yung pangalawang equation natin. Now, itong triangles na to are actually similar triangles. Now, with that information, you can actually just use ratio and proportion to have yung second equation mo. Okay, so ratio and proportion tayo. Y over 2, Y2 over 2.5 is actually equal to Y1 over 7.5. Oh, di ba? Equation 2. Equation 1, matik na. Okay? Sir, very easy. Okay? Very easy, sir. So, I'll substitute ko yung Y2. So, 1 minus, Y1. Ikaw, sir, meron palang ganitong method, sir. Hindi mo sinabi, sir. So, guys, ito lang yung method na gagawin ninyo if ever may quiz tayo. But, sa board exam, ito din. But, sa mga plates, anyway, bibigyan ko na lang kayo ng specific method sa isang problem na gagamitin. Or, isang problem lang siguro, and then, try to solve using different methods. Depende na. Tama ba? 1 minus x over 2.5. Tama na? I think tama naman. Tara! So, y1 is actually 0.75. And then, obviously, since 0.75 yung y1, diba? Ang y2, 0.25. Sabi kasi 1. Diba? So, ano yung i-add mo sa y1, 0.75 para maging 1? So, 0.25. Yan na, guys. Okay? De, check natin yung, yan na. Diba? Yan yung sagot natin dito. Check nyo. Yan yung sagot natin. Yan, oh. Diba? Same sila, oh. Okay. Now, let's try to solve yung number 3. Diba? Yung 1 hour and 30 minutes natin na discussion para dito, naging 10 minutes lang sa Euler-Lewis law. So, construct the influence line for the moment at point C of the beam. Okay. So, moment at point C naman sa beam. So, same pa din. I'll try to draw the beam. Okay. And then, okay. So, I'm interested sa moment at point C. Okay. So, sa moment at point C, same pa din. I will cut the point C Okay? So, ikakat ko to. Pag-cut ko dito, guys, ay, may narinig kayong, anyway, sorry guys. So, anyway, pause ko muna, sandali. Asa na yun? Okay, I'm back. Sorry, naririnig nyo ako, guys. Okay, sorry. Sorry. Saan na tayo? Yan. Okay, so, i-cut ko ha, yung beam dyan, and then, ang mangyayari, guys, ay, sorry. So, ito yung mangyayari, ganyan, and then, ganyan. Okay? So, again, I am interested sa moment. So, instead of shear yung ilalagay ko, of course, moment yung ilalagay ko. Okay? So, lalagyan ko ng moment. So, pag ganyan, and then, pag ganyan. Diba? And then, ano yung sabi niya? Let the beam deflect or rotate. Actually, mas maganda pag rotate. Anyway, may support dyan. So, hindi yan mag-rotate dyan. Paano yung rotation niya? Ganito, oh. And then, yan yung para sa kabila. Okay? So, paano mag-rotate yung kabila? Ganito, oh. Be, agree kayo? Okay lang? Thumbs up daw if naintindihan. Diba? So, sir, matik na, sir. Wala na, sir. Very easy na, sir. Perfect. 5.0 na, sir. By the way, sa CIT, sa mga nanonood, 5.0 kasi yung plot 1 sa amin. Anyway, ano ba yun? Ang problem lang natin, guys, pag meron na tayong influence diagram, okay? Pag meron na tayong influence diagram, wala din tayong ordinates, di ba? Ito. Anong to? Now, gaya ng sabi ko, ay, tawagin ko na lang tong ano ba to? H1 and then H2. Okay? Now, ang H1, guys, at saka H2, obviously, the same lang sila, no? Kasi, same lang kasi ang base nila. Anyway, I need two equations kasi nga 2 yung unknowns ko. Now, kung kanina, dalawa yung unknowns ko, H1 and H2. Kung kanina, guys, sa shear at saka reaction, kung saan ka nag-cut equal to 1, dito sa moment, hindi siya equal to 1. Okay? Paano natin isolve yung ordinate dito? So, meron tayong formula, guys. If meron kang, halimbawa, ganito yung, if ganyan yung sa moment mo, kung saan ka nag-cut, guys, ito yung hinahanap natin, no? Tawagin natin H1. If this is A, and this is B, okay? To solve for H1, actually, guys, that is equal to, okay, tandaan nyo to kasi hindi ko nilagay sa notes. That is actually equal to, ano nga ulit yun? A, B over A plus B. Yan. Check nyo ha? Ano yung A at saka B natin? 4, no? So, check na natin. 4 times 4, okay? Divided by 4 plus 4. 4 times 4, 16. Divided by 8, 2. Okay? Matik. Diba? H1 is 2. And then H2, obviously, from ratio and proportion, H2 and H1 equal yan. Okay? 2.0 din to. Okay? So, ito yung una mong kukunin ha? Yung una mong kukunin is yung nandito. And then, how can you solve for the other ordinates? Just use ratio and proportion. If you can actually solve one ordinate sa influence line na yan, you can solve the other ordinates. Okay, using ratio and proportion. So, yan na guys. Diba? See, napakadali. It took me 10 minutes to discuss yung Mueller-Bris law, but yun nga, hindi nyo maintindihan yung third na method if, okay, hindi nyo nakita yung previous method. So, ganun ba din? So, kaya nag-explain pa din ako sa yung dalawang methods. Okay? Sorry. Hindi ko napansin, may mga chat pala kayo. Sige. Anyway, guys, so after nyan, guys, ang mangyayari, sir, sir, yes, alam na namin paano gumawa ng shear and, influence diagram. Ano yung silbi nito, sir? Yun nga yung sinabi ko sa inyo. Using the diagrams, kasya pa ata sa 20 minutes. Anyway, using these diagrams, guys, you can predict, okay? You can know kung saan natin ilalagay yung mga moving loads to have a maximum positive shear, maximum negative shear, maximum positive moment, or maximum negative moment. Kailangan kasi natin yan later on sa design, okay? Sa steel at saka sa RC ninyo. Now, let's try to check daw paano ba to, ano ba yung application nito? Okay? So, I think okay na, I think okay na tayo no, sa Mueller-Bris law na method. Let's check yung application of influence line for beams. Now, the application of influence line for beams, guys, actually is madali lang. Okay? Ang gagawin natin is from the influence diagram, okay? pwede natin, alam na natin kung saan natin ilalagay yung live load. Now, yung live load natin dito guys, we will just consider 2 loadings. By the way guys, tingnan nyo, once the influence line for a function or reaction, shear, or moment has been constructed, it will then be possible to position the live loads on the beam which will produce the maximum value of the function. Yung nga, anyway, papakita ko sa inyo kung paano. And then, dalawa lang yung loadings natin. We have the concentrated load concentrated load, and then the uniform load. Now, dito guys, sa mga problems na to, ang itatanong na is, what is the maximum moment at point C? Or what is the maximum positive moment at point C considering these live loads? What is the maximum negative shear at considering this? Ganun. Okay? So, ang gagawin natin guys, to solve for those values, okay? Ito yung mangyari. To solve for that value daw, ang concentrated load, just multiply that, okay, by the ordinate. Tignan nyo? Multiply by ordinate. So, in a way, yung function natin, yung makukuha natin na value, for example, you are asked to solve for the, ganito na lang, function natin. Either pwedeng R, reaction, pwedeng shear, pwedeng moment, depende na yan. So, anyway, the value daw dyan is actually, okay, pwede daw na i-multiply. So, yung P, force P, or yung force, yung concentrated load P natin, just multiply that by the ordinate. Ordinate, ganun lang. Ganun lang. Okay? Now, the uniform load naman, i-multiply mo lang, yung uniform load naman, i-multiply mo lang sa area, nandito pala, nakalimutan ko. So, the value of the function daw caused by the uniform load is simply the area under the influence line. So, ilalagay ko na dito. So, yung uniform load natin, usually W, no? W. So, W times area. Yan. Diba? Napakadali. So, let's try to check daw. Paano natin gagawin to? Now, let's check this problem. Itong problem na to. Yan, yung problem na yan. Example pa. So, sa problem na to, tinan nyo yung tanong, determine daw the maximum positive shear. Okay? Determine the maximum positive shear that can be developed at point C in the beam shown due to a concentrated moving load of 4,000 pounds and a uniform moving load of 2,000 pounds per foot. Okay? So, paano kaya natin yung gagawin, no? Kayo, paano natin gagawin to? Okay, so the first thing to do, guys, is notice na this is actually a moving load. Okay, moving load, and then uniform moving load din na 2,000 pound per foot. So, to get the maximum positive shear dito sa C, maraming possible na location ng moving load. Kasi yung moving load kasi, guys, pwedeng ganito. For example, yung concentrated load. Malay ko ba kung pwedeng dito yung concentrated load? What if nandito yung concentrated load? Diba? Or what if nandyan? Hindi natin alam. Okay, but how can we check na maximum na pala yung shear sa C? Now, same goes for the uniformly distributed load. What if nandyan yung load? Or what if nandito lang yung load? Okay, or what if yung whole span talaga nandyan yung load? So, hindi mo alam. Okay, now, it will take you napakadaming combinations, no? Na napakadaming shear, okay, na makukuha mo sa C. But since you are just interested sa positive, now dito na papasok yung influence diagram. I-draw na natin yung influence diagram sa C. Ano yung sinabi ni Euler-Bris law? Cut the C. I am interested sa shear. Apply ko ang positive and yan, shear. So this is actually 2.5. This is 7. Uy, same lang to kanina. So anyway guys, down, okay, and then ganun. Okay? So same to kanina guys, so walang problema lang pala. Yan. Okay? So yan yung influence diagram natin sa C. Okay? Now guys, we are interested, sorry, medyo nag-error. Okay? Now guys, we are interested dito sa ano yung tanong kanina? Yan pala. Ay, sorry. We are interested sa maximum positive shear. So guys, ito yung gagawin natin. To get the maximum positive shear, you can actually apply the load, okay, the loads, kung saan, of course, nandun din ang positive area. So ano yung gagawin natin? Ganito, paano ba to? Asan yung positive area, di ba? From 2.5 to 7.5. Therefore, ito yung placement ng load ko. Ay, sorry. Ito yung placement ng load ko. Yan, yung uniformly distributed load, dito ko pala ilalagay. Ay, sorry, nagkulang. Dito ko pala ilalagay to get a positive shear. Now, ang tanong, asan ko ilalagay yung concentrated load ko? Now, sabi kanina, the value daw of the function is equal to the concentrated load multiplied by the ordinate. So, to get a maximum, okay, maximum value, try to put the concentrated load sa maximum ordinate din. From our figure, saan dyan ang maximum positive ordinate? Obviously, nandito. So, ilalagay ko yung load ko dyan. Therefore, therefore, ito yung mukha ng beam mo, ito yung mukha ng loading mo, okay, para makakuha ka ng maximum positive shear sa point C. Okay, now, ang tanong, hindi yan yung tanong. Ang problem natin, guys, hindi yan yung tanong. Ang tanong kasi ang tanong sa problem is, what is that value? What is the maximum positive shear? Hindi tayo tinanong kung ano yung itsura ng beam to get a maximum positive shear. But, of course, kailangan natin yung itsura na yan para ma-solve natin yung positive shear. Now, there are two methods that we can actually use to solve for the shear at C. Okay? Now, the first method, guys, is use statics. Yung ginawa natin kanina, solve the reaction and then cut and then solve the shear at C. Okay? Now, the other one is we will try to solve using the influence diagram. Now, depende na sa inyo kung ano yung gagawin ninyo. But, later on, you will find out that it is mas madali actually. Since meron na tayong influence diagram, mas madali na yun na lang yung gagamitin natin. Now, by definition, ano yung, by definition, no, yung gamitin mo na natin yung influence diagram natin. So, the shear daw at C, the maximum shear at C daw is equal to, ano yun? P times ordinate, okay? Multiplied by W times area. Okay? So, ano yung shear sa C? So, ang P, guys, is equal to, ano yung P ulit natin? Yung load natin? 4,000, no? 4,000 yung load. So, 4,000 multiplied by the ordinate. Ano yung ordinate natin, guys? 0.75, di ba? 0.75. And then, plus, ano yung uniformly distributed load natin? 2,000 pounds per foot. So, 2,000. Ano yung area, guys, ng diagram natin? Okay? So, the area of our diagram is the area of a triangle. By the way, guys, ito lang we are interested sa positive shear. So, positive areas lang ang i-consider mo. So, positive 1/2. Ano yung base natin? 7.5, no? Ang height natin is actually 0.75. Okay? So, with that, you can actually solve VC. I hope tama yung equation ko, no? 4,000 times 0.75 plus 2,000 times 0.5 times 7.5 times 0.75. Tama ba? 0.75 yan. Okay, so yung maximum shear natin is actually 8,625. Yan na. Okay, yan na, guys. Now, meaning, yung shear na yan, yan yung gagamitin mo to design your beam, okay? Kung ang stirrups mo later on sa reinforced concrete niyo, yan yung gagamitin mo, guys. Dapat yan yung allowable, okay, sa beam mo. Okay, provided yung mga reduction factor, mga ganun. Later on na lang. Which is why importante talaga yung theory. Kasi itong theory subject na to, ito yung foundation nyo later on sa ano tawag nun, sa RC, foundation niyo sa steel, no? Good luck, no? If ever nakapasa kayo sa theory without understanding yung mga concept talaga. Okay? Now, the same goes, no, na dapat importante din yung statics para maintindihan nyo yung theory. Okay? Now, check nyo, guys. You can actually still solve the reaction. I mean, you can actually solve the shear then, okay, by not considering this method. You can actually just solve, no, yung reaction dito unto 4,000. And then this is actually 2,000 pounds per foot. Okay? Now, let's try to solve down the shear dito. Okay? By statics. Anong gagawin natin? I'll try to rotate na lang. Sum up moments. Solve ko to. RA pala, RA. Kaya pa ba? Tama. Meron pa tayong 5 minutes. Okay? So, RA. So, I'll try to sum up, ano ba to yung dimension natin? 2.5, 7.5. Okay? I'll try to sum up moment at B equal to 0. Same ba din? Clockwise is equals counterclockwise. Okay? So, ang clockwise moment natin, guys, obviously, we have our reaction, RA, multiplied by 10. Now, that must be equal to the counterclockwise moment, which is equal to, wala nang ibang clockwise, 4,000 multiplied by 7.5. I hope obvious, no, yung mga moment arms. Okay? I hope obvious na 7.5. Hindi na kaya yung lalamunan ko. Okay? So, and then, plus, W L squared over 2. Ay, hindi. Yung shortcut yan. So, plus yung load natin, which is 2,000. Okay? Multiplied by the span of the load, the 7.5. Again, this is the reaction. And then, multiply that by half of yung length ba, ng 7.5. Okay, so 7.5 over 2. Bakit? Yun nga, gaya ng sabi sa statics, ng reaction ng rectangular load, nandyan sa gitna. Okay, so meaning yan. So anyway guys, you can actually solve RA. Yeah. So check na natin kung 4,000 times 7.5 and then plus 2,000. Natatakot ako guys na baka marinig nyo yung kapatid ko kasi nandito sa kabila natutulog. Baka marinig nyo yung snoring ba. Sorry. Na ngayon sinabihan ko kayo, I think hinahanap nyo na yung tunog. Okay, so anyway, 10x pala yan. Ano yung sag? Di ba? 8625. Sir, reaction man yan, sir. Hindi man yan shear. Yes, hindi yan shear. But, tingnan nyo. If I will try to cut the beam here, i-cut ko yung beam, ha? Di ba? Cut ko yung beam, RA. Okay, and then yan. This is actually the shear at C. Ano to? 8625. Di ba? Therefore, VC is actually 8625 then. Summation of forces vertical is equal to 0. See? So, sir, pwede pala sir na statics lang yung gamitin. Bakit pa tayo influence diagram? Okay? Now, ang mangyayari guys, yes, gumamit ako ng statics to solve for that shear. But hindi ko masosolve yung ito ba ito? Hindi ko alam to, ito. Hindi ko alam yan. Hindi ko alam ang figure na yan kung wala din ako nito. Which is why, very important pa din yung shear diagram. And since nag-solve ka naman sa shear diagram, ito na lang yung gamitin mo. And then later on, promise, mas madali ito, di ba? P times Y plus W area compared sa isosolve mo using manually. And then anyway, ang purpose naman talaga ng influence diagram is to avoid solving manually. Dapat ito na yung gagamitin mo. Okay? Therefore guys, ito yung gagamitin mo, ito yung shear na gagamitin mo later on. So, yan yung sagot natin sa example number 4. Okay? So, anyway, I think medyo kinulang tayo sa oras, no? Anyway, ipopost ko na lang yung YouTube link sa YouTube channel ko i-send ko na lang sa mga nag-organize dito sa tutorial. Anyway, yan lang muna, guys. I was actually planning to teach you yung mga influence diagram for the bar forces sa trusses, but rest assured, pag naintindihan nyo yung kanina, yung first method, which is yung nagpe-place tayo ba ng loads at different points, you can actually easily solve yung influence diagrams for trusses. So for now, yan lang muna guys, at least natutunan nyo. So anyway, if ever hindi to kasali sa midterm exam ninyo, rest assured, this will be included sa final exam ninyo. But sa part ko, this is actually included sa midterm exam sa mga students ko. So shout out again sa CA361 M4. Anyway, yan lang muna guys. Maraming salamat. So, I think ibabalik ko kayo sa MC. So, kunin nyo ulit. Maraming salamat. Balik tayo dito. Salamat. Yan, okay.